Hi everyone, I am Ekansh. I am a software engineer with SigNoz, and SigNoz is a open source, open telemetry native observability platform. And here with me is Shivay. And
Yeah, hi everyone, I'm Shivay. I'm a Senior Ambassador and Dr. Captain, and looking forward to this talk.
yeah, so let's get started with the session. We have already discussed about platform engineering with you folks. So what we are going to talk about in this session is that we wanted to design platforms with judgment, some platforms which are proactive in nature and not just reactive, and how do we achieve them with MCPs, the agentic flows with MCP. So the session title is as written, designing platforms with judgment. Let's go with what are the traditional platform engineering practices. So I have like a couple of years of experience in platform engineering teams now, and the things that are in common with all the teams is that human intervention is the most needed in a platform engineering team. So let's just say I want to develop an application and I want to deploy it over GitHub, like push it over GitHub for something. So we push the code and it triggers a CI/CD pipeline. It can be either GitHub Actions, it can be Jenkins, and the deployment goes through Argo CD or some other CD platform that you are using. Apart from that, we need some pipelines to build it and run it in production. And once that whole application is there in your Kubernetes cluster or in your environment, you would need some kind of observability. So I would prefer like OpenTelemetry as your default observability standard, but you can use any of the backends such as SigNoz, Prometheus, Grafana, which will collect your metrics, events, logs, and traces, your general 4 pillars of observability, to figure out if something is going wrong with your application in your environments. Apart from that, once that is done, once that is sorted, your application might be running fine, your application might not be running fine. So that's where incident management comes in. And for incident management, you need something like PagerDuty or Slack alerts or something like that, where engineer is always on call. So there have been days where I have been on call for like 7 days straight. So I know the pain points where I get a PagerDuty alert and I need to be active. My SREs needs to be active. So a lot of human intervention is always needed. So why is platform engineering so cumbersome? So as we discussed, uh, it is very reactive in nature. It is not very proactive in nature. There is no standard awareness. Everything is a human person should have that context, and scaling this model is hard. So we recently saw that there was a big outage for like CrowdStrike. There was a big outage for other platforms as well, and it affected everyone. So that was a large scale outage for everyone, and a lot of people were needed for that. So coming to what and how platform engineering has been evolved in the last 5 years. So in the last 5 years, there has been a declarative and event-driven system, so such as GitOps, and there has been infrastructure as code. Apart from that, there has been explosion of telemetry data throughout your platform engineering channels. So with the advent of OpenTelemetry, we have a standardized way to get metrics, logs, and traces. And then we also have platform engineering, like developer platforms to figure out what is going on. So that is also here. So IDPs are also there. And the biggest challenge for that is that we want to create a self-aware platform. So what is the rapid growth of LLMs in the cloud native industry? I am asking ChatGPT to fix my platform, and ChatGPT is asking me to fix my platform. I am asking what's the problem. He's telling me probably he might know, he might not know, like, and he is giving me some prompts to run on my platform. So basically, human intervention is still needed. Then what is happening here? So LLMs are great in giving us suggestions. So example is if you have used Cage GPT, Holmes GPT, they are good at giving me like suggestion about your Kate's cluster, but they are not the ones who are fixing it. I am the person who needs to figure out, okay, if this is right or wrong, and then I have to fix it myself. So a lot of manual intervention is needed. So enters MCP. So what is MCP and why? Why is it so much on the boom? Why is everyone so hooked up on MCP? Shivay will tell us.
Yeah, so as we already Yeah, okay, perfect. So as we already saw that LLMs are great at being able to understand context, but at the same time, you have to remember that they are still based on a transformers architecture. That means they are outputting tokens, which means that they're not really great at being able to execute tasks, right? So the natural progression for us was that when ChatGPT was launched back in 2022, it is great at being able to answer queries to you, but we wanted for it to take a more proactive approach at also being able to do tasks for you. And the most basic way of handling that is something called as function calling or tool calling, which enables your LLMs to be able to get access to external APIs, get access to your database, so that now the LLM can understand context from them and reroute the request based on the context to be able to make an API call based on user's behalf. And that naturally led us to the conclusion or introduction of MCP. And literally in just 1 year, in fact, it is not even 1 year since Model Context Protocol was launched as a protocol by Anthropic. I think it was exact date was 24th of November. So we are still about 10 days to complete 1 year anniversary. And we are literally seeing so many companies within the CNCF, or if you go throughout the entire booth here, the number of booths, everyone talking about Agentic AI or MCP, right? We are clearly seeing a very quick adoption. And the reason behind that is very simple. So first of all, what exactly is Model Context Protocol? So it is an open standard protocol which enables or gives wings to your LLMs to be able to connect with different kind of tools and understand context and be able to do things like connect to your database, automatically create a Slack alert for you. And of course, the bigger question is, how does it happen? So we'll uncover that. So at its core, what you're seeing here is throughout this particular diagram is that LLMs are somehow being able to connect with, like, let's say, RESTful endpoints from your Google Drive, or they can connect with large scale apps. Maybe your sales team is having a lot of sales data in your Salesforce, and they're able to now get insights into, okay, how much sales did I make in 1 year, and you're able to get responses. Or maybe even if you're trying to manage large scale infrastructure, it can contact or it can interact with your AWS cluster and get you details about your resources, resource consumption, all of that through this Model Context Protocol. So what's going on behind the scenes? So ultimately what's happening here is that Model Context Protocol, it basically is governed by this underlying way in which the LLMs are actually able to interact with what we call as these MCP servers. So MCP servers are nothing but they are just a set of different MCP tools and a description of these tools, right? So imagine that you have an MCP server for a database. So in this case, you'll have a bunch of different tools that do different operations on the database. So for example, you could have an MCP tool to just write a SQL query. You could also have another MCP tool to describe what all different buckets or scopes I have inside of my database. And the idea would now be that all of these are combined as one MCP server for my database and have descriptions of all of the different tools and what these tools are supposed to do. And these tools are nothing but just function calls, right? They are functions that do something. And the MCP client is what is allowing the LLM to be able to interact with all of these different MCP servers by using different kinds of protocols. So we have like remote MCPs, we have SSE, and these are all different ways of communicating, like how we have different HTTP standards. Similarly, you can think of like an HTTP amogelis for the MCP servers. And this describes how the flow of information between the LLM and the MCP client with the MCP server takes place. So that's the entire crux of how we are able to get these Model Context Protocol to be able to then allow the LLM to be a part of this setup where now it has access to so many different kinds of MCP servers, and we'll be showing you some examples today as well that allow us to automate that. And here is like this is a very simple example. So this is actually an example taken from the official Anthropic MCP guide. So here we are using JavaScript, but you can see that we create an MCP server, we describe what that MCP server does, and then we can add number of different tools. So every MCP server will have an X number of tools that all have a description, and by using the LLM, we can identify which particular tool will be most useful for a particular job at hand. And that's how this entire setup basically works. But we'll look at how we are now using this entire model context protocol and how it's empowering platform engineering. So there are a number of different ways in which platform engineers can use MCP to make platform engineering more proactive, right? So one of the key things we saw was that there is a lot of manual intervention needed, whether it's trying to understand your OTel logs and trying to decipher what problem we are facing in our current setup, or maybe the other one was imagine that you're working in a startup and you're really curious about or cautious about your AWS costs, or maybe your cloud costs. So in that case, what if you could have a scenario where an MCP can automatically understand if you're having less traffic, it can automatically scale down your resources or maybe scale it up if it is automatically able to understand the context behind your current traffic without a human having to manually do that all the time, right? Because generally we see that SREs are always at their job, and there can still be some misses that might take place. So the entire idea is whether it is being able to proactively scale down, scale up your resources, your infrastructure, or it is being able to also scan your entire application code for security vulnerabilities. All of those can be handled with the help of MCP, because they are contextually looking at what's happening in your application, both at the code angle, but also how users are actually interacting with your application. And you could set up your MCP tools to be able to look at those. And right now we'll see some examples with some blogs as well, or demos as well, that we'll showcase that you can see on how we are proactively empowering platforms with the help of Model Context Protocol.
Hi. So let's see how the platform engineering architecture has evolved using MCP. So currently we have some developer who has pushed the code to our GitOps operator. Through that GitOps operator, it checks if the commit is right, if the issue is okay, if everything is working fine, and then it starts a new CI/CD pipeline. So let's just say it starts a GitHub action, and a CI is gone, then from there Argo CD and everything is going into play. After that, it checks the infrastructure, if the application has been deployed successfully, if the pods are up, if the containers are running, and all that stuff. And then we come to monitoring and observability. So as soon as the application is deployed and users are interacting with that application, we want the melt data of how the users are interacting, how the functions are working, if those functions are working correctly or not, if the probably, let's just say a payment service, if the payment is going through or not, if there is some error or not. And then if there is any error, if there is any problem with that particular scenario, it will generate alerts. And then at the final step, if you see, there is human intervention for everything. If I am checking alerts, there is a human intervention. If I want to check the logs, there is a human intervention. If I want to see if the Argo CD sync was successful, there was a human intervention. But now, how it has evolved using agents. So if we go to the right hand side of the architecture, we see that now the developer is just pushing the code to a GitHub repository. Probably a developer might not be even needed, because there are different MCP servers which already does that. In our demo, we will show that I do not even have to push my code. The MCP server will push the code itself. So a developer is there who has written his application, and they have probably pushed the code to a GitOps operator. There is a MCP-enabled GitOps operator which will figure out the context from that particular repository. It will also figure out all the necessary information, like the cost impact it will have, the security impact it will have, and probably the OTel signals it will give, and the infra state of the your platform at this point of time. Then a new thing is triggered, which is called a decision engine, as to how to act on this particular set of signals that I got from the earlier step. So the decision engine will figure out if I have to act on it, if I have to apply these changes, if I have to push these changes to a Kubernetes cluster or not. And if not, if there is some error, then I have to escalate it to some SRE or some other MCP server. So there can be an MCP server to MCP server scenario as well. So let's just talk about a demo that I am going to show right now. So the demo is something like we have installed an application front-end code, which is calling a backend code. And yeah, right now the backend is giving 200, so the front end is also giving 200. Now what happens is that we have broken the code somehow. We have probably pushed the wrong commit. We have probably done something. There was a problem with the Argo CD syncs or something like that. And because of that, we see a 500 error on the backend, right? So now I am getting a lot of errors now. So what do we do next? So I go to some MCP server, and now that I know that there is a problem, I am using Kagent. So Kagent is a popular MCP server with K8's community. So I go to Kagent, I ask Kagent, can you please check what is wrong with it? So Kagent can use a lot of different LLMs for figuring it out, but primarily in the demo, we are going to use OpenAI for this. It will figure out what the problem is, and we can ask Kagent to just push a like fix for the problem in the GitHub repository. It will push a fix to the GitHub repository, and we can sync the Argo CD, and we will see that everything is fixed after that. So coming to the demo, yeah. So coming to the demo, let's try to figure out if we can do it right now. Yeah. So if I go to the setup environment, I see that I am creating a new cluster kind, and I am installing a bunch of stuff earlier. So I have Argo CD setup, and then I have Kagent setup, OpenAI setup. I have installed everything here. And once that is done, I also put in my GitHub personal access token so that when I want to push a new PR, the MCP will be able to do that. So I go to my terminal, I go to my Kubernetes cluster, and I can see that everything is set up. I have the Argo CD application, I have the Kagent setup, I have the I have other things. I also have observability agent here and everything else. So let's just start with port forwarding everything so that we can see. So let's just start with accessing Argo CD. Let's just start with accessing Kagent UI, and let's just start with also port forwarding the front end and the backend service. Yeah, I go to my Google Chrome to check what is going on. So localhost 9090/UI. Right now I see that everything is perfect. 200 responses coming up, right? What I will do is I will intentionally break this thing. So I will go here and I will say break.sh, and it will manually break and push a commit which will break my like the backend application. I can go to localhost 8080 for my Argo CD server. I can sync it. I will sync it, and I can go back to my service, and I can refresh, and I can see that there is an error here, right? I can check my Kagent. I will go to my Kagent UI, which is port 8082. So localhost 8082. I go to my GitOps agent because it will be able to push a new PR. So I will go to my GitOps agent. I have managed a bunch of prompts earlier. So I will go to the prompt for that. So the prompt is this. So there has been an error. So please tell me what is the error. So let's just see if there is an error. It will try to figure out what is the error right now.
And in the meantime, like what's happening under the hood is that Kagent is having a bunch of different MCP tools at its disposal. So as you saw that we were able to choose between different types of Kagent flavors. And the idea is that it has different kind of tools. So for example, the GitOps agent will have a tool to be able to make a GitHub PR. And of course, it has also different tools to be able to debug and understand your code base. So the idea is all about that how you can use the LLM to route the LLM to be able to understand the context that's happening, and then route it to the appropriate MCP tool call, execute that tool call, get the response back, and take the next step of actions as an agentic AI application would basically do.
So now what Kagent has figured out is that when we did that uh, break.sh, so it actually changed the target port from 1990 to 1991. I can go ahead and check that in my application, in my repository as well. If I go to the repository, I check that application.yaml, and I see that, yeah, here it has changed the target port. Now I will just ask Agent to fix this by creating a new PR. So I will ask it to create a new PR. I have given him the GitHub repo name. I will just say GitHub repo name and just create a new PR for the same. So it should try to call the GitHub MCP server and create a new PR with the fix for the same. So we are just waiting for that.
And in the meantime, like this to kind of give you a crux of what's basically happening behind the scenes is that as now we have given this prompt, it will now reroute it to the appropriate MCP tool call. Now, of course, what you saw was kind of in a manual setup, but you could always automate this by using some of the open source different kind of agentic open source tooling, for example, LangGraph, LangChain, CAgent from Docker. All of them can be used as part of your entire pipeline so that you don't have to manually then write these prompts. This is more to kind of give you an idea that how it basically works behind the scenes, right? So this can be done on the server side as well completely without the use of an UI. Just to show that how Kagent basically thinks and does those things, like we just wanted to quickly show an example.
Yeah, it's taking a bit of a time, and I will like to blame that on the current Wi-Fi issues that we are having right now.
But yeah, to be respectful, we did already have a demo recording as well, so maybe we can quickly
so
just
we will
jump
show
to
that. And what has happened is that it figured out, I asked him to create a new PR. So yeah, I asked him to create a new PR. It figured out what needs to be done. It created a new PR for us. I went to that PR, I merged it, and after that is done, I went to Argo CD, synced it back, and yeah, everything was fixed after that. So that is one of the examples of using MCP for this, and there is another demo that Shivay is going to give.
So the next one is more about how you can do root cause analysis. So the idea is very simple, that we have so many traces, logs, metrics coming all the way. And of course, at times, what we want to do is we want to do a couple of things. One is we want the LLMs to be able to automatically understand the problem that we are seeing right now through just by analyzing the logs. And secondly, also take proactive decision based on that. If it knows how to automatically make a fix for the customer, or if it's a new problem, then it can create a Slack alert, or it can create a PagerDuty alert, so that your SRE team is not always getting overburdened with so many metrics or traces coming all the time, and especially for smaller startups that might not have a very large team at play. So what we're going to be seeing is, and this is, of course, being governed by something called as Docker MCP catalog and toolkit. So the entire idea is that today, because these MCP servers have to be hosted somewhere, so how can you secure them? How basically you can host a bunch of these MCP servers that you could basically also keep inside of your entire org. So Docker basically introduced their MCP toolkit, which allows you to find some of the most popular MCP servers, and these can also be hosted on Docker Hub, similar to how you host your container images, and you can host some of these MCP servers. And if you're using something like Docker Desktop, or even if you're using your local Docker CLI, you can find the list of all of the different servers. And also, if your MCP servers have some secrets, maybe if you have, like, let's say, a SigNoz backend, so you'll need like a URL and an API key for that, you can securely save all of that inside of your MCP server, and secret management you don't have to worry about all of that. So we are quickly just going to show you an example here. So what we went ahead and did was that we set up a SigNoz dashboard. And SigNoz, if you're not already aware, it's basically a service or an open source tool that collects all of your logs with the help of the Open Telemetry Collector, and it visualizes all of them, right? And now what we're going to be doing is that by understanding that if there are some issues with my traces or my logs, I'll pass this MCP server to my agent and enable it, so that if I ask it, okay, what are some of the issues that I faced in the last 35 minutes. So here you can see that I'm asking how many errors are there in my SigNoz traces in the last 35 minutes and what is the root cause. It will actually go ahead and be able to identify all of that for me. So here you can see that my SigNoz MCP server has all of these different tools like get alert, get logs for alert, or even execute some prompt query kind of queries. And all of these are enabling me to understand what's going on in my SigNoz dashboard, understand what is the root cause. So here you can see that for me, I had about 142 errors for get operations, and these were the failures. And it also gave me the root cause diagnosis by being able to intelligently reroute the different requests, not only just being able to identify that there is an issue, but because it has access to so many different tools that can interact and can identify the root cause by seeing how different things are linked inside of my SigNoz dashboard. And all of this is, again, being powered by this Docker. And over here, what you're seeing is that we are, of course, running this as part of Docker Desktop. But you could also use other types of model registry. So in fact, MCP also has its own registry where you can publish your own MCP servers as well. So Docker is just one way of being able to do it more effectively. But that is a quick example. Now, of course, you could have made it even more proactive by introducing like, okay, I want to create a Slack alert. Or you can give it what we showed in the last one, which was the MCP was automatically able to create a PR and fix something for you. So you could merge all of them together as a single pipeline and create much more proactive agentic workflows that can manage all of that for you and help you to debug your platforms in a more easier manner.
Yeah. So let's just see very quickly as to what Cloud Native Computing Foundation has for us in terms of agentic platform engineering. So there is a new thing called CAPE, which is the Community AI Platform Engineering. It is open source, it is multi-agentic AI system, and it is championed by the CNOE, which is the Cloud Native Operational Excellence, which is also a part of CNCF. CAPE provides a secure, scalable, persona-driven like implementation, and it streamlines innovation. So it can be used with IDPs such as Backstage, or it can be used in developer environments such as VS Code. So CAPE has a lot of agents by itself. So we have the Argo CD agent for continuous deployment. We have the PagerDuty agent for incident management, GitHub agent, Jira agent, and a lot more agents that you can see.
And yeah, so the basic idea is that as a community for CNCF, we want to see how we can empower all of the backend platforms, whether it's Backstage or not. So here is like a high-level architecture of what's basically happening. So under the hood, it's using a bunch of different agents. And as soon as you find any issue in your entire Backstage, so whether it's like an issue on OTel, or maybe it's an issue with your code or security, it can reroute it with the help of these protocols. So there is an A2A, which is an agent-to-agent communication protocol. This was released by Google, and it complements well with MCP, because with MCP you allow the agents to be able to interact with different tools and different services. So by using a combination of all of them together, you can basically now see that depending on the use case, it will reroute it to the appropriate agent, and that appropriate agent will then use an appropriate MCP. So if you're having a bunch of MCP servers in your Docker catalog, you could have like your GitHub MCP server, PagerDuty MCP server, all of them are there in your setup, and based on the context of what's happening, it will reroute to the appropriate and take the appropriate proactive action. And the last thing is, about security. So MCPs are not secure, right? We have, in fact, seen so many different kind of horror stories around secrets being revealed because people simply didn't know how to use these MCP servers properly, because there's an entire concept of LLM security and prompt injections and all of these that we don't have time to cover today. But MCPs themselves is not like a magic potion that will solve all your problems. And in fact, there's a really nice article on the Docker where it talks about the supply chain attacks that have taken place on MCP. And only recently we had the OAuth 2.1 to be able to add more security to MCP servers. But that means that, of course, it's not completely production ready. And Ekansh will probably cover more about this in the conclusion.
So let's conclude the presentation. So we got that agentic platforms are very context aware. It's policy driven, and if we give the right amount of context to it, it's also very if we do it correctly, it is also very secure. But we are not there yet. So MCPs are very powerful, as we have seen, but it is still lacking maturity. Now, coming in the loop of this platform engineering, humans need to be in the loop to actually see what is going into the prod environment till we do not find the to reach the exact maturity of MCPs. And before shipping to prod, we need the rigorous testing using observability and fallback controls and all that stuff. So that has been our talk regarding agentic flows in platform engineering. You can reach out to us on Twitter using these particular handles. And thank you so much. If you have questions, we will be down on the ground to just help you out with it.
Thank you.